The concept that we're going to discuss is VTP today. So we saw how VLANs work, we saw how trunking works, we saw how inter-VLAN routing also works. Now it's time to see a concept that is called as VTP. And VTP stands for VLAN Trunking Protocol. Now let's say that we have a switch over here, which is switch 1, and that switch is connected to another switch, which is called as switch 2, and then we have another switch, which is switch 3, and we have a user that is connected to our switch 1, that has user A along with the IP address 192.168.1.2, let's say. Okay, and the MAC address that it has is AA, and the VLAN that it's allocated with is VLAN number 10, meaning that we can consider that the port that is connected over here can be 0 slash 1. Okay, and the port that it is connected with 0 slash 1 itself. So we have another user, that another user is B, having an IP address of 192.168.1.3 with a MAC address of BB and with the same VLAN configuration, VLAN 10. And the interface that it's connected with is also 0 slash 1. So, and it can be fast Ethernet or gigabit Ethernet, whatever interface that is. Okay, the number, however, is 0 slash 1. Then after that, we are connected with gig 0 slash 2 and gig 0 slash 2 over here. And let's say gig 0 slash 3 and gig 0 slash 3 over here. And assuming that we already have made these as trunk links. So this is a trunk link and that's a trunk link as well. Now, having such scenario in consideration, do you think or do you believe that if I try to send traffic from A towards this link and then here, will this communication be able to work? Can A communicate to B via over here, having everything configured as given into the topology? Would this communication be possible from A to B? Okay, let's try and implement this thing in our packet tracer. So I'll just share my other screen. So I am creating the same topology in our packet tracer. Say we take three switches, switch, and then we also take a couple of PCs with us. And then we connect these together. So FA0 slash 1 to 1, FA0 slash 1 to 1. Then we connect these together. Good. Then we will fast forward it, go to the IP, and we will configure our first IP address as 192.168.1.1, and then press tab, and we don't really need a gateway here. So I'll close it down, I'll go to the other PC, and we'll go to the desktop section, IP configuration, and we'll say 192.168.1.2 and tab. And if I try to send traffic from, I would say, this link to this link, then it should work. You see that? Successfully delivered. So because everything currently is in VLAN 10, right? Sorry, VLAN 1. And now what I'm gonna do, I'm gonna make this FA0 slash 1 participate into VLAN 10. And I'm gonna make the FA0 slash 1 on the other switch 3 participate into VLAN 10. So let's go on our first switch. And on the first switch, what I'm gonna do is enable conft. I will just name the switch as SW1, and I will go into the interface FA0 slash 1. Oh, sorry, we'll just first create a VLAN with VLAN 10 name PyNet. And then we will say interface FA0 slash 1. And I would say switch port access VLAN 10. Correct? And then the interface will just restart. Then meanwhile we will go to the other switch, which is the switch 3, and we will say enable, then conf t, then interface, sorry, conf t host name SW2, the spelling there, SW3, sorry, and then VLAN 10 and say name, same name, PyNet. And then we will also make FA0/1 participate into switchboard access VLAN 10, so that both the end devices are basically member of VLAN 10. We can verify the same by performing do show VLAN brief. And you can see that FA0/1 is a part of our VLAN 10. And if I turn this CLI down and then after this interface would come up because it will restart, I'll just fast forward it and it's green. So when I try to send traffic from this PC to this PC now, it will not go. Okay, why so? Any reasons? Because of middle switch, right? And this particular, I would say, link is not up here. So what we will do, we basically will create a trunk link on this. And if I go ahead and say interface FA0/2 and say switch port mode trunk, then I would go on to the other switch as well, and I will make both these interface as interface range FA0/1 and 2 switch port mode trunk, and then I will go on this particular link and say interface FA0/2 switch port mode trunk. So when I do this configuration, and now both my links are trunk, but if I again try to send traffic, the traffic will just not go. You get that? And why is this particular reason? Because that whenever the traffic is being received from this particular PC on this switch, then this traffic is being tagged with VLAN number 10. And then that traffic will be sent across to this link. But when that traffic reaches out over here, then we need to check that whether this switch 2 understands this VLAN traffic or not. And how does trunking works is trunk basically builds up a table and checks up a list that how many VLANs is it allowed to send traffic of. So if I check my trunk table on switch 1, then I can just check that by running a command called do show interface trunk. And you can see that my switch 1 allows VLAN number 1 and VLAN number 10, correct? And it can send traffic because it has VLAN number 10 in its list, in its VLAN list. But if I go ahead and check the same thing on my switch 2, I'll just name it as hostname SW2, and I'll say do show interface trunk. So you will see that we have these two interfaces configured as trunk, but it only allows VLAN number 1. Why so? Because when we check the VLAN, I would say table on our switch 2 by running a command do show VLAN brief, you would see that there is just VLAN number 1 and every port is part of that specific VLAN. And what would be the solution over here? That if I just go ahead and add this VLAN 10 in our VLAN database and name it something like PyNet, the same thing. And then if I again go ahead and check my trunk table, then my trunk would now allow sending traffic from VLAN 10 as well. So what trunk links does, trunk basically copies the VLANs that exist in your VLAN database. Okay, and it allows those VLANs to send traffic and receive traffic from. That's how basically trunk works. And now if I try and send traffic from here to the other PC, then you would see that the traffic gets successfully delivered. Do you understand that? Correct? So now this is kind of a drawback that the architecture has, because if you go ahead and let's say in a bigger topology, if you have a network in which your source and destination needs to go through 10 transit switch, then it would not be a good idea to go ahead on each and every switch and create these VLANs, right, on each and every transit switch where the end users are not even there. In that scenario, we use something called VTP, which stands for VLAN Trunking Protocol. And when we use this VTP or VLAN Trunking Protocol, then what it does is it advertises something called VTP Advertisement. And in this VTP advertisement consists of VLAN database of the VTP server, and every other switch will copy that VLAN information in their own VLAN database. Meaning that whosoever sends this advertisement, okay, if this advertisement is being sent from switch 1, then that advertisement will contain all the VLAN that switch 1 has. And then every other switch will copy the number of VLANs and create the same VLANs in their VLAN database, so that whenever there is a traffic, that gets satisfied. Okay, do you understand that? Meaning that if my switch 2 now doesn't have this VLAN, I would say no VLAN 10. Okay, and take an exit. And if I say show VLAN brief now, you would see that VLAN 10 doesn't exist. So what I'll do, I'll just create a VTP domain over here on switch 1. Okay, and every other PC will participate into that domain. Make sense? And then your VTP advertisement will be sent if you kind of create a new thing. So what's gonna happen is, as soon as I create VTP domain CCNA, let's say we will name it as VTP domain CCNA. You can create VTP domain by using VTP domain command, and I will name it as CCNA. So as I hit enter, you can get a message that changing VTP domain name from null to CCNA. You get that? And what's gonna happen is you can verify the same by using a command do show VTP status. Okay, do show VTP status. And as you look into that, you can see that the VTP domain name is set to CCNA. And then you can verify the same thing on the others as well. So if I go on switch to and I say I say show VTP status, you would see that VTP domain name is CCNA. Make sense? Then I will go on the other switch. And if I go over here and say show VTP status, do show VTP status, then you would see that VTP domain name is CCNA here as well. So this VTP domain information is synchronized everywhere that you go. You get that? And what is going to happen basically, as soon as you create your VTP domain, then the VLANs would probably be removed from the switches. So when I created this VTP domain, you can see that if I go ahead and say do show VLAN brief, then the VLAN 10 doesn't really exist over here. So what are we going to do? I'll check each and every VLAN. So VTP show VTP domain, show VLAN brief. You can see there's no VLAN 10 that exists, and I would say show VLAN brief. There's no VLAN, show VLAN brief. So you see VLAN 10 doesn't exist over here as well. And what's gonna happen is whatever changes you're gonna make, those changes will be sent in a form of advertisement to every other switch. So I will go on this particular switch and I will say VLAN 10, and then I would say namespace PyNet with PyNet VTP, let's say, so that you understand that this is the new VTP that was created, and that's not black magic, I would say. So after creating this, we will verify the same, and you can say PyNet VTP has been created. Then I can go on second, I would say switch, and verify the same by running do show VTP command. And then you can say that PyNet VTP is there as well. And you can also see the same thing on switch 3 as well, PyNet 3. Do you understand that? And then you need to go on your switch and assign interfaces to it. So I would select interface FA0/1 switch port access VLAN 10, correct? And then I would say go in my interface FA0/1 on switch 3 and say switch port, or it already has that specific member assigned to it, right? So do show VLAN brief. Yeah, FA0/1 is assigned there. And then if I try to send traffic, the traffic will just go successfully delivered. Make sense to you? If I just go ahead and configure our VLAN 20 as well, okay, and name it as new, then you would see changes on switch to do show VLAN brief. There you go, new is there, and do show VLAN brief. New is there as well. And if I see my trunk tables, they will allow the number of VLANs that I have on my VLAN database 1, 10, and 20. Make sense? So just one switch makes VLAN and configuration via VTP to make all the other switch, and then every other switch will copy the same information exactly. So this switch, our switch one over here, will act as VTP server, which creates and which is responsible for all the VLAN database. Okay, and then we will set the other VTP, I would say devices as VTP client and VTP client. And what happens is when in order to set these as VTP client, because by default every other PC is a VTP server. Make sense? So as switch one has created this VLAN, if I go on switch two and say no VLAN 20, then what's going to happen? This VLAN 20 has been removed, right? Show VLAN brief, and you can't see any VLAN 20 now. So if I go on my first switch as well and see do show VLAN brief, you see VLAN 20 has been removed. So only server should be able to create VLANs and delete VLANs. That's why we assign other switches as VTP client. And how do you do that? You go to the switch. In the conf mode, you say VTP mode client. Get that setting device to VTP mode client. And then I will set the other device as VTP mode client as well. Make sense? And what will be the result? You will not be able to do any modifications to the switch now. If I say do show VLAN brief, you have only VLAN 10, right? If I say VLAN 20, I want to create VLAN 20. It says VTP VLAN configuration not allowed when the device is in client mode. And I can even cannot select our pre-existing switch or pre-existing VLAN and then make any changes, name admin. It says nothing, not possible. So only VTP server has the ability to play with the VLAN database. The only ability that you will have on client devices is make these ports as members of those VLANs. So if you see your VLAN 10, it only has one member, that is FA0/1. So what you can do on client device is you can go to the other interface, let's say 0/5, and make it a member of VLAN 10. You get that? And then you can see that do show VLAN brief is VLAN FA0/5 also is member of that. So that's what you can actually do by using this VTP. Do you understand that? How VTP actually works and what it does? So I'll try to do the configuration again probably. I'll delete this whole thing and explaining. And please pay your attention while I'm explaining. And when you acknowledge that we understand, then I'll just take these three switches and two devices and connect these two devices over here. And then these two are connected as well. Okay, I'll go on each and every switch and name our switches as enable conf t host name switch 1. Then I will go to the second switch and I'll say enable conf t host name switch SW2. And I would go on my switch 3 enable config host number SW3. You get that? Then I go on this particular PC and assign an IP address to it 192.168.1.1, and then I will assign an IP address 192.168.1.2. You get that? Then I'll just make these as trunk links. Correct? I just made all these links as trunk links. And then these links will just shut down and turn off. And then I will create VLANs on switch 1 and switch 3. So now what I'm going to do, I'm not going to create VLAN on each and every switch. I'm just going to create a VTP domain. As you can see that there is no VLAN. Do show VLAN brief. You can see that only VLAN number 1 exists there. So I would say VTP domain CCNA. This is the command to create a domain. And it says changing VTP domain name from null to CCNA. And then you can see that other devices would also have participate into same. We show VTP status. See, the VTP name domain name is CCNA. And over here as well, the VTP domain name is do show VTP status as it have not configuration. Okay, now the state came up. Has not participated in VTP. Okay, if your switch doesn't participate into the common VTP domain, then you can make it participate into the VTP domain by saying VTP domain CCNA. Okay, but the names should be same, because what happens is if I use different name, because the name of the domain is going to be case sensitive. If I say CCNA like in caps, then you would see kind of an error here that VTP domain mismatch happened. So if I say do show VTP status, then this is participating in VTP. Probably there is error on this. No, both the links are also trunk. FA0/2 is also trunk. 0/2 over here also is trunk. Yeah, there you go. The error is there. Unable to perform trunk negotiation on port 0/2 because of VTP domain mismatch. So names must be same. So I will just change the name again to small CCNA and match it with others by running VTP domain CCNA. And you can see my information will be synchronized. Do show VTP status. And there you go. Good. Then I will go ahead and create VLAN 10 on our first switch. And you see VLAN 10, name PyNet, and take an exit. And then you can see that on switch 1, you would be able to see do show VLAN brief. And PyNet is there. I would go on the other switch, do show VLAN brief. And PyNet is there as well. And do show VLAN brief. PyNet is there as well. You get that? So the devices or the VLANs are created locally. But the only thing that you need to do locally is you need to assign the interfaces manually to the VLANs that have been created. You get that? So we will go into the interface and say 0/1 needs to be part of VLAN 10. Switch port access VLAN 10. and then take an exit. And then I would go on this device, switch 1, and say interface FA0/1, switch port access VLAN 10. Makes sense? And then I can verify my VLAN database by running a do show VLAN brief command. And you would see that FA0/1 is part of this VLAN 10. And the interface will just restart. And when it's green, you can send traffic from here to here, and it will be successful. And then last thing is you need to make these two switches as clients, and we will run a command called VTP mode client, and it says setting device to VTP client mode. And then I can again go and say VTP mode client, and then these two switches will not be able to create any VLANs then. This is how it actually works. Make sense to you? So go ahead, do this lab, okay, and let me know when you're done. Then let's understand another, I would say, aspect of this particular lab, that there is a thing called CR number. And what the CR number stands for, it's configuration revision number. And how the CR number works is you can just check the status by running a command called show VTP status or do show VTP status. And in this do show VTP status, you can see that configuration revision is set to 2. Okay, now this number by default is set to 0. And as soon as you create a domain or so, then you would basically be able to like create VLANs and do all the modification that you need to do in your VLAN database. And if you just say that how many VLANs do we have, we'll just figure that out. We have one VLAN that says VLAN 10, and the configuration revision number is 2 now. So as I go ahead and say VLAN 20, okay, and then take an exit, now we can see that do show VLAN brief would give us the new VLAN as well. That would be VLAN 20, right? And if I again check my VTP status, then you can see that the revision number now is 3. So what happens is upon doing each and every change in your VLAN database, the CR number will be increased by 1. Okay. So, and why is it increased? Because that whenever this number is increased, then VTP advertisement is sent, and the receiving switch will verify that if the advertisement consists of higher CR number, then it means that that local switch needs to make the change. If the CR value is lower than the current CR that exists on this VTP configuration on the local switch, then it assumes that the information that is being provided in this advertisement is not latest to the information that the switch carries. So that's why CR number will be increased and the advertisement will be sent with increased CR number, that will be 3. The current CR on switch 2 will be 2, and then upon doing the changes it will also be set to 3, and same will happen over here, and everything will become synchronized again. Make sense to you? So that's why CR number will be changed upon each and every change that you do. Either you add a VLAN, create a VLAN, remove a VLAN, rename a VLAN. Every VTP VLAN changes will kind of result in increasing the CR number by 1. However, someone is asking that what is pruning? Pruning is not something that is, I would say, explained in this beginner course. Pruning, you need to have proper understanding of layer 2 and some advanced things to understand pruning. So we are not going to touch pruning as of here. Okay. So that was our VTP. I hope we are good with it. So we'll move ahead to the next topic that we need to discuss, which is HSRP. Okay, and HSRP stands for Hot Standby Routing Protocol. Okay, Hot Standby Routing Protocol. Now there is a thing called FHRP, which stands for First Hop Redundancy Protocol, which consists of 3 protocols. One is HSRP, okay, which Then the second one is VRRP, Virtual Router Routing Protocol, and the third one is GLBP, okay, which is Gateway Load Balancing Protocol. All these protocols do exist in order to create redundancy and automatic switching of interfaces whenever you have redundancy configured. And why do we use it? We are going to explore only HSRP over here because other two are also the same thing. And HSRP is kind of Cisco's proprietary, and VRRP and GLBP are open standard. Okay, so we are going to explore HSRP over here. So I'll just create a topology which simply looks something like this. We're gonna have a router and the other router, and we'll have another router over here. And I'll just place this router somewhat apart over here. And I will also place three switches like this. And then I will also have a couple of PCs over here and over here. Then I will make these connections. So I will connect this switch here and the switch here and the PC here. And then here, here, and here. You get that? This is how the topology looks like. And what we're gonna have locally, we're gonna configure 192.168.1.0/24 network over here, and dot one will be given, or let's say dot 11 will be given here, and dot 12 will be given over here. Then we will also have another network called 192.168.2.0/24, about which dot one here, dot two here, and dot three here. And then we will also have a network called 192.168.10.0, about which dot one will be given over here, and dot 10 or dot 2 will be given here through DHCP or so. Do you understand that? So that's how the communication is going to happen. And we are going to configure RIP throughout so that this PC will be able to communicate with this PC. And we are going to configure DHCP on our router 1 and router 2. Do you understand how this topology is going to work? Perfect. So I will go on my R1 and do the configurations. I will say no over here, and then enable conf t interface fa0/0, no shutdown, and then IP address 192.168.1.11, right? And then I will also configure a DSCP for this network. Let's say IP DSCP pool A, and say network 192.168.1.0, 255.255.255.0, and default is going to be 192.168.1.1. So for R1, when we are going to configure DHCP for R1, we will set R1's IP address as default, correct? So that's going to be 1.11. And then we will go ahead and configure the R2 as well. But before that, we will also configure this 2.1 address on FA1/0. So I will go ahead and say interface FA1/0, and say no shutdown, and then IP address 192.168.2.1. Good, along with the subnet mask. So that's what the configuration needs to be done on R1. Then we will go on R2 and do the necessary config. So I'll go on R2, no enable conf t hostname R2 interface FA0/0, no shutdown, and then say IP address 192.168.1.12 along with the subnet mask. And then we will also configure a DHCP pool for it. Let's say B, and then say network 192.168.1.0 along with the subnet mask. And default address would be 192.168.1.12 here. Do you understand this? Okay. Then I will go on interface FA1/0 again, and say no shutdown, and perform an IP address config of 192.168.2.2. Get it? And we are done with the config. So as of now, there are two DSCP servers for this network, correct? One is R1 and the other one is R2. So when this particular PC is going to send DSCP discovery message, these both the PCs, there are chances that both the routers are going to receive that discovery message. And whosoever replies to the user first, he will be the one in order to configure that IP. Okay, the default is configured as 12 because the IP address of the interface is 1.12. Okay, Tejas. So we will go ahead and configure DHCP address on this on the PC, and let's see. Okay, the R1 kind of is acting as the current DHCP server. You see that the default gateway is of 1.11, and then we will go ahead and configure this other network as well. So I'll go to the third router, which is this, and configure IP addressing on it. So we'll go no enable conft hostname R3 and say interface FA0/0, no shutdown, IP address 192.168.2.3 needs to be configured over here. And then we will go and interface FA1/0, no shutdown, IP address 192.168.10.0 or 10.1, sorry. We good? And then I will also configure DHCP pool. Let's say C and network 192.168.10.0, 255.255.255.0, and default is 192.168.10.1, and take an exit. That's what R3's config looks like. Are we good? I'll just go to the last PC and configure the IP of via DHCP on this. And there you go. Now our network will still not be able to communicate from here to here because routing is not implemented, right? So I'll go on R1 and I'll create a RIP instance. So I'll say router RIP version 2, and I will advertise my two networks that are 192.168.1.0 and 2.0. Correct? Then I will go on the other router that says R2 and I will say router RIP version 2 and network 192.168.1.0 again and 2.0, and take an exit. And then I will go ahead and say on router 3 router RIP version 2 network 192.168.2.0 and 10.0. Do you understand that? And if I check the routing table on R3 now, you can see that our 1, 2, and 10 all are learned. And if I now try to send traffic from here to here, our communication will be first failed, and I will again try to send that. Again failed. Why? Oh, there you go. Successful. So I'll again try to send that. Successful. Are we good with the topology? This is the base topology that we need. Then what HSRP is, so who is acting as the default gateway? It is R1, right? Meaning if I go ahead and go to the I would say command prompt of this PC and say ping 192.168.10.2, which is this device, right? The ping is working. But if I use another utility called tracert and I say tracert 192.168.10.2, it will basically track all the devices that it's crossing in order to reach out to 10. So it says first I went on to 1.11, then I went on to 2.3, and then I went on to 10.2. You get that? And when this happened, it means that the default gateway is actually receiving the traffic first. So if I go ahead and shut down this interface, what is going to happen? The traffic will go from the other way. The traffic will not go to the other way. Let's see that. Interface FA0/0, I say shutdown. You see the interface is down now. And if I try to send traffic from here to here, it says in progress failed. I will again try to send it. You see, it's not able to go through the other link. Why the other link is still active? And why is this happening? Because the PC still retains the IP configuration that has been given to it by the DHCP server. It has a lead time of 2 hours by default. And that's why, until unless this IP address is not, or the gateway address is not changed, till then the PC will still assume that it needs to forward the traffic to 1.11. And what is happening over here is when the PC is trying to ping to 10.2, it will face an error that request timeout. Make sense? And if we try to do traceroute over here, the first hop needs to be the gateway, right? So it again is not able to go there. So what do? We basically say go to the PC and again change the IP config from static to DHCP, and then it will request a new address and it will get new DHCP gateway. That is 1.12 now. And then when we try to send traffic now from here, ping 10.2, you see the ping is now going. And then if we try to do trace it for the same, you can see first the traffic is now going to 12. You get that? And what would happen if the interface again comes up? The interface is now again on. So will traffic go from the first interface again? No, it will not. It will still go to the 1.12 first, and then it will go to the other devices. Why so? Because the gateway configuration is still the same, 1.12. Now this is not called load balancing. Okay, in order to do the balancing, what you need to do is you need to configure a standby IP, because HSRP works by configuring a standby IP, and that IP address will be a virtual IP address, which will be, let's say, the last IP address 1.254. And this standby IP will be configured on both R1 and R2, and that virtual IP also will be acting as the default gateway on the PCs. Do you understand that? So when you configure your DHCP, you need to use this virtual IP address as your default gateway. You get that? So what are we gonna do there? We're going to go on R1 and we are creating the standby IP by using a command as simple as standby. No. We need to go to the interface first. This interface on which is facing towards the PCs. So we'll go to the interface FA0/0 and we will say standby IP 192.168.1.254. You get that? And take an exit and also make changes in your DHCP pool. After creating standby IP, we go to IP DHCP pool. What's the name of my IP DHCP pool? Do show run section DHCP A, right? IP DHCP pool A, and I would say default would be 192.168.1.254 and take an exit. And then go to the other router, say interface FA0/0 standby IP 192.168.1.254. Then go to IP DHCP pool B and say default 192.168.1.254. That's what you need to do the change. And then you can go onto the PC and again request the DHCP. And you see the new IP is 254 now. And what happens now? One router will act as an active router, the other one will be acting as a standby router. So if I try to send traffic from this PC now, let's see what gateway is it using. You see, it's still going through 1.11. The IP will be used as physical itself. Okay, the gateway is not highlighted as 254 over here because that's a virtual IP address. So it will show that it is going through R1 1.11. And what will happen if R1's interface goes down? Interface FA0/0 shut down. And you see, HSRP state change. The fast Ethernet 0/0 state active to init. Makes sense? And if we go on the other router, you can see that it became from speaking to standby, but now it became from standby to active. So automatically, this particular router became an active router. And now if I try to send traffic again, the traffic is going through 1.12 automatic switching. Make sense to you? So that is exactly how it works. And these routers, which are basically acting as active and standby, communicate every 3 seconds with an hello message. If the hello message is not received for 10 seconds, then it will assume, the standby will assume that active is no longer active and it will announce itself as active. Okay, so there is a hello and dead time of 3 seconds and 10 seconds respectively. Do you understand that? Perfect. So go ahead, configure this thing. The only command that we used was standby IP 192.168.1.254 by going into the interface. So we went into interface FA0/0 and we configured this IP and changed the default gateway in our DHCP settings. Make sense? Go ahead, do this particular lab and let me know when you're done. All right. So I guess most of you are done with the lab. And that was the content that we had to cover today. So we are almost done with the layer 2 thing. There are two things that are left about layer 2, which is STP spanning tree protocol, and then we'll be talking about ether channels. These two are the things that we'll be discussing on the next class. So I hope you enjoyed today's session, and that was it that we had to cover today. Thank you so much for attending the session today.